Hello and welcome to the Redox reaction split lessons. This is the first lesson about this internal assessment, and in this presentation we're going to talk about what are redox reactions and how to write a half equation. So redox stands for reduction and oxidation. So reduction is reduced to red and oxidation is reduced to ox, and together we get redox. Okay, so it's just a shortening of those two terms. Now, redox reactions are initially described in terms of addition or removal of oxygen. So it was all about, in a chemical equation, when something had oxygen added to it, so for any combustion reaction, any sort of burning, we are reacting an element with oxygen to make oxides. So for example, if you burned magnesium with oxygen, you'd get magnesium oxide. So because you're adding oxygen, that would have been called oxidation. Now the opposite of that would be when you're removing oxygen from a compound like aluminium oxide, and so you're purifying the aluminium out of it, so you're taking the aluminium and removing the oxygen, and in that case we call it reduction because we've reduced the amount of oxygen. So for the following, you're just needing to write down an O or an R for whether something's oxidized or reduced. So I'll do the first couple with you. So magnesium's forming magnesium oxide. So we're adding oxygen, aren't we? Because we've ended up with an oxide, so that's an oxidation. Iron ore is iron with oxygen, and we're removing that to make just simple iron, so that must be reduction. So you can carry on with that. Now, the term redox has since developed, and now it's all about electron transfer rather than worrying about the oxygen. So remembering all elements contain electrons, which were first discovered by J.J. Thomson, and when they discovered electrons, they now redefined redox to mean that when an element loses electrons, then we call that oxidation, and when an element gains electrons, we call that reduction. Remember, electrons are negative, so if you're gaining a negative thing, then you end up with less because they're negative. So that's where those terms come from. Now, a way of remembering this is this memory jog oil rig. So oxidation is loss, is what oil is signifying, and reduction is gain, is what rig signifies. So that's how you can remember. Oxidation is loss of electrons, reduction is gain of electrons. Okay, so when we're doing redox equations, we wanting to record what's happening as far as electrons. So in a redox reaction, there'll always be something that has gained electrons, and there'll be something that will have lost electrons. So something gives away its electrons and something gains them. And when we do these half equations, we're showing that something has lost them and something's gained them. So we start off with these half equations with this sort of part. We know that, say, magnesium has become the magnesium iron, so Mg has gone to Mg2+. And so now we've got to write in what has happened in terms of electrons. So when all metals become positive ions, they're giving away electrons. So I always tell my year 11s that when you're giving away electrons, think of it like giving away eggs. If you give away eggs, that's a positive thing. So magnesium has given away a couple of eggs and it's become a positive ion. Now, when you're writing these half equations, you can just see, well, in terms of charge, there's a 2 plus charge on this side, and there is a 0 charge on the element side. Okay, so when magnesium's an atom, it's got 0 charge. When it's an ion, it's got 2 positive charge. So now we're going to add electrons to the most positive side. So the Mg2 plus side is the most positive side. So we want to add enough electrons to make both sides of the arrow equal. So if we've got 0 charge on this side, I want to have 0 charge on this side. So 2 plus 2 minuses is going to balance out to make it overall neutral, equaling the left side. Okay, so for this first one, for A, just look at it. Sodium's on the left, sodium ions on the right, and the most positive side is this side on the right, so that's the side we're going to have electrons. We've got 0 charge on the left, and we've got 1 plus charge on the right, so I'm just going to add 1 electron to that. Okay, you can just write an E, you don't really need to have an E minus. Now for B, we've got 0 charge on this side. Because it's Cl2, I need to have 2 Cl ions on the right. So whenever we're doing chemical equations, when there's a big number in front, that means everything after it is doubled. So this means that there's 2 negative charges on this side. So because there's 2 negative charges on that side and there's 0 charge on this side, which is the most positive side? That's right, it's the left. So we have to add electrons to the left to make it the same as the right charge. So overall it's neutral. So if I've got 2 negative on this side, I have to add 2 electrons to this side. Okay, so now you go and see if you can do that with these 2 in your workbook. And there should be some more examples.